So, can you hear me? Yeah. What we're about to discuss is relatively new. It's moved out of the embryonic stage of development to the fetal stage to now it's a newborn. And that is the subject matter and research regarding the genetics involved in the development or causative agent of pulmonary hypertension. Since the Human Genome Project finished up, we've been able to map DNA pretty routinely, and it's now becoming a tool, a clinical tool, being able to map somebody's DNA and determine whether or not you can make prognostications about their future, et cetera. It also provides us, I think, with an opportunity to look at how we can treat certain patients and expect positive results, and how treating those same children or adults, but they have a little bit different genetic makeup with the same medicine, will not result in a positive result. So this is going to help us with a more directed therapeutic intervention over time. It's not necessarily going to happen today or before I visit heaven, but it's going to happen. Let's talk a little bit about the genetics of pulmonary hypertension. Really, the first gene associated with pulmonary arterial hypertension was discovered in the early 2000s. The work had started with the Human Genomic Project, but they didn't really find one until I think it was 2001. And that was the bone morphogenic protein receptor type 2, which is associated very tightly with familial pulmonary arterial hypertension. There are rare variants or mutations of greater than 20 genes that have been associated with all 5 different classes of PAH. And I think that's amazing. So there's genetic variation in all of these people that develop pulmonary hypertension for whatever reason, whether it's a hole in your heart or what you're going to be talking about after this session is over, which is chronic thromboembolic pulmonary hypertension. The interesting thing about this is that there are these unique contributions to our understanding mean that we can apply genomic sequencing to the cohorts, different cohorts of patients with pulmonary hypertension. And then we're going to get into some of these different registries and cohorts in a moment. So what? Who cares? What do I want to know about my genes? Some people don't want to know about their genes. And some people don't want their insurance company to know anything about their genes. But we're all clinicians. And for us, knowing whether or not we can help somebody, whether we can tailor their therapy, whether we can give them an idea of what's going to potentially happen to them over time, I think that's important to us as clinicians. And so these are some of the reasons for doing genetic mapping for pulmonary arterial hypertension. It's for the benefit of the patient, which is why we're all here anyway. Now, I like to call it pulmonary arterial hypertension gene hunting. We're looking for genes. Now, there are a lot of people doing this around the world. And I do literally mean all over the world, maybe the possible exception being probably the African subcontinent, the African continent, but almost everywhere else, there are people working. So there are a group of geneticists or clinicians that are working to map out the different types of genetic changes that can occur in patients with pulmonary hypertension, and it all goes into a registry. They're combining multiple registries so that this information all can be located in one place. and this is the Clinical Genome Resource Center. The URL is there. You can go and visit it. It is comprehensive to date, but remember, we're just getting started on this gene hunting. I think that what you will find is that things change literally every year. There are new gene mutations that are found to be and confirmed, because confirmation, as you can see up at the top, is important. Just because somebody reports that they found gene XYZ and it's specific for pulmonary hypertension and truncus arteriosus doesn't mean that's true. It has to be confirmed at least one other time for it to become considered even possibly. And we're going to go into that. There's a sequence of events that has to occur in order for you to finally say, guess what? Yes, this is definitely associated, this mutation is definitely associated with this type of pulmonary hypertension. So these are at the bottom, you'll see that there are 12 currently gene mutations that are classified as having definitive evidence that they are involved in pulmonary hypertension. Only 12. We've been doing this for 21 years at this point. So it was a slow go to start with, and it's expensive to do this gene mapping, and you have to have a good patient population. Now, there are 3 genes with moderate evidence. So I told you a little bit about it. Well, you said, oh, this occurs in truncus. Well, yeah, but who else is going to prove it? So it has to be corroborated at least 3 times to make it to moderate evidence, okay? And then there are 6 genes that say, okay, a couple of people found it, but we don't have enough corroboration yet to believe that this is actually involved in it. And then there are a number of genes which have been disputed right now, as some say yes, some say no. So these are probably going to fall out in the future. Most of this moderate evidence genes has been found in the last 5 years. So there's been a lot of work done. What I'm suggesting to you is get ready, because there's about to be an explosion, literally, of research in the area of the genetics of pulmonary hypertension. I don't know if we should thank President Clinton for the genomic mapping program or not, but at any rate, it's being done. Now I agree, this is kind of hard to see, but I'm going to give you the reference of where you can find all of this material later. So this is the current status of 13 different programs that are being run, whether it's been confirmed. So you can see all the way over on the right-hand side, the third column on the right-hand side says classification. So definitive, 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 but then all of a sudden, you get down to moderate evidence, okay? And then before this is over with, before this table is completed, you're already to limited evidence. And the limited evidence goes on, and some of it just, quite frankly, has been disputed. Dr. Bob in Moscow, get ready, I'm using that for a particular reason, comes out and says, oh, look what I found. And then Dr. Igor in Kharkiv says, no, you didn't find that. That's the disputed. And so there are a number of disputed gene malformations that really may or may not turn out to be associated with pulmonary hypertension, but someone has reported in their series of 1 that they found this gene associated with pulmonary hypertension. Now, why are we doing this? Who cares? Okay, 1, as we are able to determine that specific genes occur with, or there are specific genes that occur with specific types of pulmonary hypertension, you'll be able to give a prognostication to the patient about what their expectations should be and how to help try and tailor their care. Because in the future, you're going to have therapy not based upon symptoms, you're going to have therapy based upon your genetic makeup. And I'm sure all of you are knowledgeable of CRISPR and gene splicing. get ready. We may not all be alive when it happens, but it's going to happen. This allows for more personalized treatment. You will be able to tell whether or not your children and their children should be worried about it. I mean, you can take the kid's blood and determine whether or not you gave them this hideous gene. I didn't mean it to sound that way, but that's exactly what we're talking about. And so as a consequence of that, you can tell early. You know, the child doesn't have pulmonary hypertension, idiopathic pulmonary hypertension, yet he's out playing football, or, you know, she's on the girls' volleyball team and they have no trouble. But then you take the sample and you say, oh, oops, you're probably going to have pulmonary hypertension later in life, so let's make some plans about this. So that's early detection. And then, you know, all of this boils down to how can we research changes in therapy that are going to impact those individuals with these particular anomalous genes. And I think for me, that's the most exciting area and the most unique area. Unfortunately, it's also the most expensive area. One of the things that hasn't been brought up, and maybe I just missed it because my Ukrainian is terrible, but you do realize that 1% of the world's population has pulmonary hypertension. 1%. It is one of the most significant healthcare problems in the world that is unrecognized and inadequately treated. It doesn't matter whether it's a kid with congenital heart disease or whether it's your grandmother with, you know, idiopathic pulmonary hypertension. But, and I'm not talking about severe, I'm just talking about any criteria for meeting for pulmonary hypertension, 1% of the world. So wouldn't it be good if we could tell who those people were and how we could modify their treatment? So I talked to you a little bit about gene hunting and the different people that are working on it. And these are all, as of 2024, May, these are all the registries that are currently involved. And you can see that, you know, you've got people, you know, in the UK, the first two are actually UK registries, all the way across the board to Japan and China. And really people throughout the world are trying to collect patients with pulmonary hypertension to help them with modifying their lifestyles so that it's easier for them to get them the right medicines like the sildenafil and bosentan that they need to make things easier for them so their 6-minute walk is longer. These are the people hunting for genes. And I think it's fantastic that we have this many registries putting their patients in looking for this. Now, rare subtypes. Okay. You will see listed under rare subtypes a little group way over here on the right says CHD-PAH, congenital heart disease with pulmonary arterial hypertension. Now, it is. I mean, it's if you look at the overall number of individuals with pulmonary hypertension in the world, I mean, I'm not even sure that children with congenital heart disease, whether corrected or uncorrected, represent 1% of all of the 1%. So it's a pretty rare group. But you see, look, you know, you've got 10.4% in one registry, 11.4% in another, and then in the very last one, 30.5% of the patients were pediatric with congenital heart disease. So it depends on where you're looking and who you're looking at and how carefully you're looking as well. But nonetheless, thank God some of our kids are in there. All right, this is the last thing that we're going to talk about. And I think, you know, I've flown through this because it's new and it's developing, but this is the reason why it's important. This, for me, is the most important slide of all of them. So all of these registries that we talked about, it's a scaled population. It's all over the world. They are longitudinal studies. We find out what happens to people, whether they're treated or untreated, depending on what type of pulmonary hypertension they have. Does it affect family members? Okay. And is it federable? Well, That depends. Depends on which country you're in, actually. The idea of being able to map all of this in genomics will give you the ability to learn what type of therapy is indicated for a specific type of gene modifying, of a gene for that particular type of pulmonary hypertension. Now, let me just say this in closing, that one gene abnormality is rarely the only gene abnormality in those individuals that have pulmonary hypertension. And you'll find that frequently they're a mixture of abnormal genes. And, you know, I do mean gene hunting. And this is going to be a tedious and expensive process, but I think this is the future of medicine, is finding out what is wrong with your particular, why do you have a disease, which gene is the problem, and can we splice it early enough in life so that you don't have this problem later on. Like I said, I'll be dust before that happens. But some of you in this room are going to see these changes coming, regardless of where you are. So this is just getting started. It's very, very exciting to me that we can, you know, find these patients, identify the genes, and hopefully alter our therapeutic interventions to improve their long-term survival. And I'm pretty sure that that is my last slide.